Welcome you all. In this session, we are going to discuss network graph, bus impedance matrix, primitive parameters, and bus admittance matrix from the primitive parameters. After successful completion of the session, the student would able to form Y bus by singular transformation method. Network graph. In order to describe the geometrical structure of network, it is sufficient to replace the different power system components, such as generator, transformer, and transmission line, by a single line element, irrespective of their characteristics of the power system components. Network is an interconnection of elements in various branches at different nodes. So the geometrical interconnection of these line elements is known as graph. A graph is representation of a network obtained by replacing every element of network by line segment and every junction by point by nodes. The terminals of elements are called nodes. A graph is connected if there exists a path between every pair of nodes. A single end or a single node is a connected graph. If every edge of a graph is assigned a direction, the graph is termed as oriented graph, and the direction is generally so assigned as to coincide with the assumed positive direction of the current in the element. So here you can see a sample graph. The power network are so structured that out of m total nodes, one node is always to be ground potential, and remaining m minus 1 nodes are the bus at which the source power is injected. The figure shows the oriented graph with a network. A connected subgraph containing all nodes of original graph but not closed path is called tree. The tree branches from subset of elements of the connected graph. The number of branches be required to form a tree is equal to the number of buses in the network, including the reference node is one more the number of buses. That is, B is equal to m minus 1, which is equal to n number of buses. The elements of original graph not includes in the tree from a subgraph which may not necessarily to be connected is known as cotree. Cotree is a complement of a tree. The elements of cotree are called the links. The number of links I of a connected graph with elements is given by I is equal to E minus B, which is equal to E minus A plus 1. Number of links is equal to the number of elements less than the number of tree branches. A tree and the corresponding cotree graph is shown. So the A diagram you can see a tree, and B diagram you can see the cotree. Sorry. If a link is added to the tree, the corresponding graph consists of one closed path called loop. Thus, the graph is as mainly loops as the number of links. The above system in the previous slideshow has 9 branches, so it has 18 variables. However, it can be easily seen to all 18 variables not independent. The number of independent variable is found from the concept of tree. The number of tree branches gives the number of independent voltages. From any such system, the number of tree branches is equal to the number of buses. The number of links given is number of independent current variables. Primitive network. A network is constituted by many branches and each branch consists of active or passive elements. The figure shows the network branch consists of both active and passive elements in impedance and admittance representation. The impedance is a voltage source in series with impedance, while the admittance of there is current source parallel with the admittance. The element currents IRs and the element voltage VRs is equal to VR minus Vs, where VR and Vs are the voltages at the nodes of R and S respectively. The noteworthy point is that the steady state AC performance, all elements variables VRS, VR, Vs, IRs, JRs are phasors of elements parameters. ZRs and YRs are complex numbers. The performance equations for impedance representation is given by VRs plus ERS is equal to ZRs into IRs. The admittance representation is given by IRs plus JRs is equal to YRs into VRs. A set of unconnected elements is known as primitive network. The performance equations is admittance form can be written for all branches. The set of these equation is a impedance form. V plus E is equal to ZI and the admittance form is 1 plus J is equal to YV. Bus admittance matrix from primitive parameters, formation of Y bus and Z bus. Substituting the equations into we can get 1 plus J is equal to YA V bus. Pre-multiplying the equation with A transpose, we have A transpose into I plus A transpose into J, which is equal to A transpose into YA V bus. Each component of n-dimensional vector A transpose into I is algebraic sum of the element current leaving from the node 1, 2 and 3 up to n nodes. Therefore, as per Kirchhoff's current law, A transpose into I is equal to 0. So at any junction, sum of current is equal to 0. So similarly, each components of vector A transpose J can be recognized as the algebraic sum of all sources injected to the node 1 to n. These components are therefore bus currents and hence we can write A transpose J is equal to J bus, which is simplified as J bus is equal to A transpose Y A V bus. Comparing the above equation, we get Y bus is equal to A transpose Y A. So this is the admittance matrix. Thank you.